Algebra 2 students. This is Mrs. Tran-Bloom. We are going to study complex numbers today. So this is sort of a revisit of what we started with imaginary numbers, okay? Complex number, students, is the largest set of numbers that you guys will be studying in this class. So that includes everything. But first, let's review some of the skills we have already studied in prior section, okay? Number 1 to 4, simplify. Express each in the simplest radical form, and remember, this is an and. That means if possible, and I meant to get a highlighter, and as a decimal approximation rounded to the nearest hundredths place, if that is possible. So 256, we want to take the square root. The nice thing about 256 students is a perfect square number. And since you guys already passed your perfect square numbers and perfect cube numbers, this is immediately 16, okay? So we don't need to use a calculator for that because there's no need. Now, negative square root of a negative 144. Now, there's a negative in the front, students, so pretend there's a negative 1 right there if that helps you out. I'm going to make it slightly bigger so I can write. So if we think of it as negative 1 in the front, square root of a negative 144 is exactly the same as negative 1 times a positive 144 under the rad. Well, we study a square root of a negative 1, okay, and a square root of positive 144. Square root of a negative 1, students, is going to be an I, right, students? So this is times. All of this right here is multiplication. Square root of 144 is 12. Again, another times, 12. Well, we always want to put our whole numbers, real numbers, together. So negative 1 and a positive 12, multiply those together first. That's a negative 12. And then times I, so that's going to be a negative 12i, and then we box that up. And again, we can't use a calculator for that because it does not have a real number. You can't really punch in a negative 1 under your calculator. So number 3 says plus or minus square root of 182. Well, if you see a plus or minus in the front, students, that means your answer will carry this plus or minus over. I mean, you really have 2 answers, okay? 182, students, it's an even number. So I know it's definitely divisible by 2. So 2 times what equals 182? So that will give us 2 times 91. Well, square root of 2 and square root of 91, neither one of those is going to help us out because neither is a perfect square number. So this tells us that we have to use a calculator only since we can't really simplify it anymore and then round it to the nearest hundredths place. So I'm going to bust out my calculator. Square root of 182. So start with a plus or minus, leave it there. Now find my calculator on my computer here. Punch that in, square 182, hit enter really quickly. And I'm going to flip my computer over to hit enter to give us a decimal of 13.49, okay? So rounding to the nearest hundredths place, students, that means 2 decimal places. So you want to look at the third digit. The third digit happens to be a 0, so we are going to keep it as 49. Now, if the third digit is 5 or higher, then you round that up, but since it's not, we are going to keep it as 13.49. So go back to our paper, plus or minus 13.49, and box that up. So we have 2 answered because of the plus or minus. Okay, number 4, we will start with, remember, if you want to, you can write a 1 in the front so you know there's a negative 1. So negative 1 times, if you see a negative under the square root, students, rewrite it immediately as a negative 1 times a positive 0.16, just like that. And even further, break that down as a separate radical, just like this, okay? This is 0.16, and remember, this is all multiplication. This is going to be a negative 1 times I. Square root of a 0.16. 16 is a perfect square number, so that's going to give us 0.4 since it's at 0.16. We will multiply real numbers together, such as negative 1 and 0.4. That will give us negative 0.4, and then we will multiply to I. That will give us I in the back. So negative 4i is the final answer, okay? So that's a review from prior section. Now, on the same section, we introduced you guys to this I, right? So I is going to be square root of a -1. And we said I square is going to be a -1 without the square root because it's an I times I. So that will help us study this new skill right here when we raise it to some large power. So I to the third. So let's talk about I to the third really quickly. I to the third, students, is the same thing as I square times I to the first, right? Because when you multiply, you add the exponent. Well, I square is what? It's always going to be -1. So this is going to say, okay, well, that's -1 times I and I to the first is the same. Well, -1 times I is -I. So your final answer of I to the third is just simply -I. Now, I to the fourth. Students, would you guys agree that it's going to be I square times I square? Okay. Well, each I square is -1, right? Here we go. So this is going to be a -1 times a -1 equals, well, negative times a negative is a positive, so it's +1. So notice how our answer so far, it's -I and +1. Well, I to the fifth. Well, I to the fifth, students, is going to be I square times I square times I to the first, right? Remember, when you multiply, you add the power. Well, each I square is -1 times -1, I to the first is just simply I. A negative number times a negative number is a positive number, so +1 times I, which is an I. Look at that. So I to the fifth is I to the fourth is 1, I to the third is going to be -I. Well, let's check out I to the sixth. Well, I to the sixth is, the goal is, could we possibly break this down to pairs of i's like that, right? Because every time you have one pair of i's, that's a -1. A pair of I means you have an I square, okay? So I to the sixth is 3 pairs, right? Would you guys agree with that? 3 sets of I square, because then, well, guys, isn't I square 3 times is the same thing as I square to the third? Okay, that's true. So that means this is allowed to say, okay, well, I square is -1, -1 to the third. A negative number to an odd power is going to be negative. So this is going to give us a -1. Wow, magic, right? Imagine what we can do with all these math powers. All right, so I to the seventh, students, we cannot make perfect sets of i's. So we can break this up because 7 power is an odd number, but we can always break it up into a power of even, and then there's 1 left over. As you can see, I to the 6, we can make 3 sets of I square, right? From this right here, I to the 6 is 3 sets of I square, and that I to the 1 power doesn't make another pair because it's flying solo. Now, I square, students, is -1 to the third times I, just like what we did on number 8. When -1, an odd number, -1's a negative number to an odd power is negative. -1 times I is going to be a -I. So I to the 7th is -I. Now let's kind of look at all of the answers so far. So your answer could only be -I, 1, +I, -1, -I. So your answer can only be really 4 different choices, right? Either positive -I or positive -1. So it doesn't matter what power you raise it to, your answers can only be one of those 4 choices. So look, I, -1, -I, +1, +I, -1, and -I. So we keep on going. I to the 8th, students, that's an even power. So we can definitely make 4 sets, okay? 4 sets of I square. So what I mean by that is I square times I square times I square 4 times. But that sometimes, especially when we give you powers of in the thousands. Are you going to sit here and write out those many pairs? No. So in mathematics, what we want to do is we say, okay, well, I square to the fourth, okay? So we know there are 4 sets of I squares. Well, I square is always -1, always. So -1 to an even power, it's going to be 1, okay? So that means -1 times -1 4 times. That will give us a positive 1. I to the 15th, students, it's going to give us, remember, it's an odd power, so it's not going to give us perfect pairs, but that doesn't mean we can't break it up to I to the 14th times a single I power of 1. Well, 14 is an even number, so definitely break that down to I square, right? Well, 14 will give us 7 set of I square and drop down the I to the first power. Well, I square, it's always, always, I hope you mumble, -1. -1 to the 7th power still. Well, negative number to an odd power is -1. And -1 times I is going to be a negative I. So that's what we're getting, okay? Right now, I would like for you to try 12 and 13 on your own. Students, on 12, you ended up with an I, and on 13 students, you ended up with a positive 1, okay? If you didn't know how these were done, please come and see us in office hours. Let's work out 14 with you. But before we work on 14, I would like for you to give that a try on your own first. If you didn't get it right, let's see what happened, okay? 1,450, that's an even number. An even number, students, we know we can make it into pairs perfectly. So 1,450 will make exactly 725 pairs of I square, okay? So I square is -1. -1 to the power of 725. 725, student, is an odd number. A negative number raised to an odd power is still a negative, okay? A negative number raised to an even power, that will give you positive. So let's formally define complex numbers, okay? So students, complex numbers are written in the form of A plus BI, where A and B are real numbers and I is imaginary. Number. So I'm going to do into some IEs, okay? Some complex numbers would be -4 plus 3i, okay? So your A is -4 and your B is 3, and I is imaginary. Now, what if we have positive 100 minus an I? Yep, that's a complex. A is going to be 100. Now remember, this can be seen as 1i, so B is -1. Okay, so A and B are real numbers and I is imaginary. Now, we could also have simply just -99. That is a real number, but also a complex, because technically we can add a 0i, right? Exactly. Now, we could also have, let's just say, 1,000i, okay? Well, the reason that's a complex, because we could technically have 0 plus 1,000i, because 0 could be A and 1,000 could be B. So can you guys see that pretty much every single number you write down constitute a complex number? Okay, so example 15 to 23 is to add, subtract, or multiply, okay? So, and guys, these are just normal. You can combine I, we can multiply I like you would a variable X or Y, okay? So the quantity of 8 plus 7i plus another quantity of negative 12 plus 11i. Remember, if you see a quantity, technically there's a 1 in the front. But what happened when you distribute a positive 1? These don't really change. So these will come out as unchanged because we are only multiplying by a positive 1. So this is a plus or negative 12, and this is plus 11i. So put all the real numbers together. 8 plus negative 12 is the same thing as negative 12. Put all the imaginary numbers together, and then you add them normally, okay? Like terms. 8 minus 12, negative 4. 7i and another 11i, that's going to be 18i, and then we box that up. Okay. 16, quantity of negative 7 plus 4i minus quantity of 3 plus 2i. Remember, if you see quantity, technically you could put a 1 in front. Well, this first one, it does not change anything because you're multiplying by a 1. So drop everything down as is. But this second one, your sign would change, okay? So this is going to be a negative 3 and a minus 2i. Write those together because those are real numbers. Write the imaginaries together. So plus 4i minus 2i. Combine those, negative 10 plus 2i, and we box that up. 17 sets the quantity of negative 2 minus 6i plus another quantity of 4 minus 5i. So students, when you are doing an addition of two quantities, the sign don't really change. So you're just gonna remove the parentheses by dropping down everything the way you see. Then rewrite the numbers, okay, where real numbers will group together and imaginary number will be together. So you can combine like terms. Negative 2 plus 4, it's a positive 2. And then those will give you a negative 11i, and box that. Let's do 18. Yep, let's see if I can move. Okay, slowly. It's thinking. Okay, there you go. 18 sets 3 times the quantity of 2 plus 4i. Students, these don't really change from your prior skill. We will distribute. Okay, 3 times 2 is 6. 3 times 4i, yes. These could be multiplied. That's going to give us 12i. And box that up. 19, you will need to FOIL. So 8 times 2 is 16. 8 times negative 3i is negative 24i. 5i times 2, positive 10i. 5i times a negative 3i, students. Okay, that means you're going to have a negative. So negative, okay, so let's multiply the real numbers first. So negative 5 times 3, and then the I times I. If you put them together like this, that will help you out. Or first, you can even just write it like this. Positive 5i times negative 3i. Okay, so this one will give us 16, negative 24, and a positive 10i. That will give us a negative 14i. Now this one is where we kind of undo what we did earlier. Group the real numbers together. Multiply those together and I times I together, just like that. So that was going to be 16 minus 14i. 5 times negative 3 is negative 15, but I times I, students, is I squared. Now we cannot leave your answer as an I squared. Earlier, we said I squared is going to give us what? I hope you said negative 1. And a negative 1 times a negative 15, students, that will give us positive 15. And those are like terms. 16 plus 15, students, that's going to give us a 31. Okay, 31, and then drop down your 14i since we cannot combine that with anything else. 20 said negative 5 plus 6 all in the quantity square. Well, to FOIL correctly, write it out twice, okay, and do, oops, this is negative 5 plus 6i, and FOIL it like number 19. Negative 5 times negative 5 will be positive 25. Negative 5 times positive 6i is negative 30i. In the middle, another negative 30i. 6i times 6i, students. 6 times 6 is 36. I times I is I squared, okay? So 25, two negatives here will make it a larger negative of 60i plus 36. And students, you may not leave I squared. We have to convert that to -1. And -1 times a 36 is going to give us a -36, okay? So -36. So if we can see that -25 can be combined with -36 to give us a -11. And then drop down your 60i because there's nothing else with that. So box that up. 21. Similarly, I would like for you to try that out and box up your final answer. Hopefully, you ended up with a 22 plus 3i, okay? If you need help of how to get there, please come and talk to us. All right, 22, let's do this one. 3 times 3 is going to be 9. 3 times 4i is going to be positive 12i. -4i times 3 is -12i. -4i times a positive 4i, a negative times a positive is negative. 4 times 4 is 16, I times I is I squared. These two terms in the middle, since they are opposite of each other, they will be canceled. And drop down -16, we know that I squared, students, must be a -1. Yep. So 9, a -16, and a -1 is a positive 16. Added together, this is going to give us 25. Isn't that magical? All right, last one for this set of instruction. -3 times -3 is a positive 9. -3 times a -2i is a -6i. -2i, I'm sorry, times a -3 is a positive, because a negative times a negative is a positive 6i. -2i times a positive 2i is a -4i squared. Okay, well, those two are the same. They should be canceling each other out. So 9 minus 4, -i squared, students, is going to be -1. This will give us 9 and -4 times a -1 is a positive 4 equals to 13. Magic. All right, so what do you notice about the last few examples? Why do you think that happened? So what I want you guys to pay attention is these right here. What do you notice about those last two examples? Okay, what is the answer? I want you to spell that out. You spell that out, okay? So hopefully you're saying that the final answer comes out to be a real whole number, because can you guys see that the two binomials, they are exactly the same, except that the sign in the middle, that's the only thing that's going to be different of each other, okay? So I notice the last two example, the signs in the middle are opposite of each other. So the answer is a real number. That brings us to the definition of conjugate pair. Conjugate pair, student, is a pair of binomials. That means two terms with identical terms. I mean, first term is the same, last term is the same, okay? Identical terms, but opposite sign in the middle. Okay, so an IE of this would be the conjugate pair of, I'm going to give you -7 minus 11i. So the conjugate pair, remember the first term and the last term should be exactly the same. But since this is a negative, the conjugate pair of that, students, is going to be a positive. Okay? Last example of this section, 24 to 26 says, find the conjugate of each, then multiply. So the conjugate, let's spell it out first, okay? Conjugate. conjugate, because if we had to answer the question, remember the sign is the opposite. So 2 plus 9i is now 2 minus 9i. 7 minus 5i, the conjugate would be 7 plus 5i. Negative 1 plus 6i, students, so the conjugate would be negative 1 minus 6i. Okay, and then the next part is said now multiply those. So let's write them together and multiply. 2 minus 9i over here, 7 minus 5i times 7 plus 5i over here, negative 1 plus 6i times negative 1 minus 6i. Okay, I'm going to do 24 and 26 with you, and I will leave you to do 25. You ready? All right, 2 times 2 is going to be 4. 2 times negative 9i is going to be negative 18i. Positive 18i here for 9i times 2. 9 times 9 is negative 81, but I times I is I squared. So the nice thing, guys, if they are conjugate pairs, the middle two terms will always cancel out, okay? So that's going to be 4 minus 81 times negative 1. So 4 plus 81, that's going to give us 85. So if you know that these are conjugate pairs, you don't have to do a lot. You only need to multiply the first two terms and the last two terms. And that's why we want to make sure we know that they are conjugate pairs first before we can do this, okay? All right, negative 1 times a negative 1 is a positive 1. 6i times negative 6i, only do this if they're conjugate pairs. It's going to be negative 36i squared. But I squared, students, is going to be a negative 1. So 1 plus 36 is going to give us 37. All right, you are on your own for number 25. Hopefully, you ended up with 74. If this is not what you got, please come and see us in office hours.